Good morning, doctor and everyone. We are from Group K. So these are our group member, ARSYAD, Hanis, WAHIDAH, QING, and me, Wu.
For question 2b, by using random number function from calculator, 50 samples are randomly chosen from Appendix 1 given. The data we classify into three categories. They are biomedical oxygen demand (BOD), dissolved organic carbon (DOC), and synchronous fluorescence spectra (SFS). So based on this data given, we did two graphs to present the data. First, types of location and its frequency into pie chart. So from this pie chart, 16 samples, which is 32% from location 3 and also from location 4. 10 samples, which is 20% from location 2, and 8 samples, which is 16% from location 1. The second graph is location within average of BOD, DOC, and SFS. So based on the graph and table, we can see that location 3 has high average BOD and location 2 has low average BOD. So average of DOC from location 2 is most highest and from location 4 is most lowest than 3 locations. Next is average of SFS. Average of SFS from location 1 is most highest than 3 locations and most lowest average of FSS is from location 3.
Assalamualaikum and hi, my name is ARSYAD. For the next question is B2 Roman. For the question of B2 Roman is test at a 5 significant level if there is a difference on the DOC reading between the location of water sources. Write the ANOVA model and its assumption. For the first step, we can create the table of DOC reading between the location of water sources. From the table, we can get the sum square total, sum square treatment, and the last one, sum square of error by sum square total minus the sum square treatment. Next, we do the hypothesis testing by H0 equal to min 1 equal to min 2 equal to min 3. For the H alternative equal to min I not equal to min J. From the sum square total, sum square treatment, sum square error, we can do the ANOVA table by including sum square, different failure, mean square, F test, P value, and F alpha. So we can do the calculation by comparing the F test and F alpha. So fail to reject H0 when the F test smaller than F alpha. We can also use the P value. So fail to reject H0 when the P value greater than alpha 0.05. So there is no difference on the DOC reading between location of water sources. For the ANOVA model, Yij equal to mu I plus the random error. For the assumption, the error are independent and identically normally distributed with the mean 0 and variance.
Hi, my name is CHEOW and I'm going to explain about question B3. The linear model that we are using is y equals to alpha hat plus beta hat x. So, in order to test the linearity between the BOD and SFS at 1% significance level, we are using the hypothesis of H0, which is beta equals to 0, and H1, which is beta not equal to 0. Below is the ANOVA table made with Excel using the 50 datas in the set. The value of f and significance f helps to test the linearity between the BOD and SFS using 1% significance level. Firstly, if we are using significance f, we can make the decision rule of rejecting H0 if significance f is less than alpha. So, we can see that significance f equals to 0.5164, which is greater than 0.01. This brings to a conclusion that we fail to reject H0. There is no relationship between BOD with SFS at 1% significance level. Secondly, if we are using f, the decision rule is to reject H0 if f test is greater than f alpha, k minus 1, and minus k. Since the f-test equals to 0.4273, which is less than 7.23, we can conclude that we fail to reject H0. There is no relationship between BOD with SFS. Above is the t-statistic table, also generated with Excel using the 50 datas. The value of t-statistic and p-value also helps to test the linearity between the BOD and SFS using 1% significance level. If we are using t-statistic, we can reject H0 if t-test is greater than t alpha over 2 v. Since the t-test equals to negative 0.6537, which is less than 2.6822, the conclusion is fail to reject H0. Lastly, if we are using p-value, we can reject H0 if p-value is less or equal to alpha. Since the p-value equals to 0.5164, which is greater than 0.01, the conclusion is also fail to reject H0. To comment on the value of R for the fitted linear model, we are going to look at the regression statistics table. R value equals to square root of R squared, which is equal to 0.09394. The R value is very close to 0. This implies that there is little or no linear relationship between BOD and SFS.
Hi, my name is Hanis. So today I would like to explain for the question B4. The question is BOD readings are assumed to have a normal distribution with mean 1.5 and variance 0.135. By performing a goodness of fit test from the result, comment if the assumptions are true. So this is the 50 data that we collect from the random data that we get from the question given. Now we do the table that containing BOD data. We calculate frequency from the 50 data that we generate. Then we count probability for each data, and we also count for expected outcome 1 and expected outcome 2. We calculate chi-square test by using the formula frequency minus expected outcome 2 squared divided by expected outcome 2 to get the chi-square test value. Now we do the hypothesis testing, which is H0 equal to the BOD reading is normally distributed with means equal to 1.5 and variance equal to 0.135. Meanwhile, H1 equal to the BOD reading is not normally distributed with mean 1.5 and variance equal to 0.135. Now we calculate the degree of freedom that we got from the expected outcome 2, which is only 5 data left, and we minus by 1, we got 4. For alpha, we decide to use alpha equal to 0.01. Then we need to find the chi-square value from the chi-square table by using alpha equal to 0.01 and degree of freedom equal to 4. We got the value 13.27 and 67. We will reject H0 if chi-square test is bigger than chi-square alpha equal to 0.01 and degree of freedom 4. So from the table that we did before, we get the value of chi-square test equal to 21.1182852. That means it's more than chi-square alpha equal to 0.01 and degree of freedom 4, which is the value is 13.2767. Therefore, reject H0 because the BOD reading is not normally distributed with mean 1.5 and variance equal to 0.135.